Kick off the recording. All right, here we are. Today we are going to talk about orchestration. And does anybody already know what orchestration is?
It's pretty much like what Compose does for Docker, right?
Yes,
Which is-
but that's a good way of summarizing it, right? But there are many benefits to orchestration that really, well, before we get there, actually, let's talk about Kubernetes first. We will be talking about just how orchestration ties into DevOps practices, but let's just start with Kubernetes because Kubernetes is the platform that we're going to be learning. And the word itself comes from the Greek word for helmsman or pilot, which symbolizes guidance and control. So that's essentially the spirit of what Kubernetes is trying to do, guide and control. It's sometimes represented as K8S. You'll see it like this. And uh, that just means basically that there are 8 letters between the K and S in Kubernetes. So it's just shorthand for Kubernetes. So Kubernetes was developed by Google, open sourced in 2014. And as an orchestration platform, it allows you to, just like you pointed out, do what you can do with Docker Compose, and that is to spin up multiple containers. But unlike Docker Compose, you're not limited to, let's say, one environment, right? You are able to spin up containers among a variety of environments. So you can have a cluster of these containers that exist throughout several and multiple hosts. It's essentially the next logical evolution to containerization. It's right, the thing that you basically want to learn after containerization because it's essentially containerization at scale. You're able to do what you can do with a few containers in your local machine across a variety of portions of your system. So it enforces DevOps practices like scalability, resilience, portability, and community, I suppose. In general, I think DevOps is a culture of collaboration and community, but DevOps is also handled differently at different organizations, and not all organizations will do DevOps right. And so not every organization might respect the community aspect of um, tools and platforms like Kubernetes. But what does this mean when it says Kubernetes? I think a big part of having this infrastructure in the first place is to be able to standardize the way your applications are containerized and deployed across the entire organization. But you also want to be able to be transparent about how that happens, right? And so the various software engineer teams in your organization will be working with you and whatever other DevOps teams are part of and responsible for the platform and architecture. You will work with them in helping them understand how to write the configurations necessary to set up their systems while you maintain the overall uh, environment from which all of this happens. So let's talk a bit about Kubernetes architecture because it can be a little hard to conceptualize. When you deploy an application on Kubernetes, you're essentially launching it into a cluster. And this cluster lives, let's say, in one single, well, for your local environment, it's going to live in one single environment. That's your local machine, right? And that's what we're going to be mostly working with here at Platoon for the curriculum, but in a real world environment, it's going to exist across a variety of machines. And what that's going to look like is there is something called a control plane, which just like we did in Ansible, works by having a master node that communicates with worker nodes. Except in this case, our master node is running Kubernetes commands as opposed to Ansible commands. And what we're able to do with these different containers and pods is we're able to do things like spin them up, spin them down, reallocate memory, kick off and trigger workflows, all sorts of stuff that's very necessary for being able to um, adjust on the fly, things like the load balancing for various parts of your application. So we will be using something called Minikube, which is essentially kind of like a what's a good word? It runs Kubernetes locally, and it kind of runs a lightweight version of it. And this is great for development because you're it's kind of impractical to set up a series of different virtual machines and nodes just to be able to try and run through Kubernetes commands. And let's see. If we scroll down here, we could see a diagram that represents what that looks like, right? So you've got a control plane that is communicating with a cloud provider API, and it also communicates with the various nodes that it spins up and down. And these nodes have various components like pods. A node can have multiple pods. They could have kubelets, kube proxies, and you could think of pods as being like the smallest deployable unit in Kubernetes, and it's one of the building blocks to the various processes that you're going to be running. Kubelets are what ensure that containers in the pod are running as expected, so they listen and return information. Container runtime, like Docker, is what actually runs container. And with your control node, you have a control manager that monitors the state and makes changes to ensure that the state is what is desired. There's also capabilities like scheduling and again, communicating with an API server. So spin up your local machines or your terminals, I should say, on your local machine, because I don't think anyone here has installed Minikube yet. There is a link that I'm going to drop in our Slack channel, and you can go over to this link and see the various installations for different operating systems. So whether you're on Linux, Windows, Mac, there's different instructions. Whether you're on Silicon or the M chips, you'll have different commands. You just want to run this to retrieve an image, which you then install with the second command. So let's go ahead and do that sometime today. Once you finish that, you should see a message like this, where kube control, it tells you that kube control is then configured to use Minikube cluster and the default name. And whoops. Let's look at what that configuration looks like. So once you set up Minikube, it's essentially going to attach itself to your kube config. So your kube config, which is going to be located inside of your home directory. Well, if you're on a Mac, I think it may be a little different if you're on WSL. or Unix. It might be very similar though. So let's look at LSA. We could see that we'll have a cube folder, and inside this folder is where you'll find your config. So let's take a look at what that looks like. Your cube config will show things like the API version, a lot of information like the local cluster that's running essentially, right? And where things like your certificate are located, servers, and here we see the name Minikube and the cluster Minikube because Minikube is what essentially set up our Kubernetes cluster for us. So again, it's a very handy little tool for simulating uh, Kubernetes and being able to run Kubernetes commands on your local machine. So this README, which I will upload later today, will also include a few things like aliases that you might want to create, right? So that you can either always run kube control with Minikube or keep it separate. And what I mean by that is when you run kube control, you're actually running Minikube cube control dash dash. So you're passing in the kube control command to Minikube in order to run it. Now, if you are going to use Minikube to run Kubernetes for the rest of the cohort, then it makes sense to just go ahead and create an alias that will run Minikube for you every time you use kube control. But you could also, if you feel like it, attach it to a separate alias like mkube control so that if you want to set up a separate cluster outside of Minikube, you can do that, and kube control will be reserved for that cluster. So regardless of which alias you choose, we will simply be using kube control for the rest of the module. If you get to a point where you're creating clusters and it's messing up your local commands, chances are you'll have to run Minikube kube control dash dash. Now, what is this dash dash? Does anyone know? The double dash is a separator argument, and it basically specifies to what you'll be passing a command to. In this instance, there's nothing that follows it, but later on when we start running commands, kube control commands, for example, we'll want to specify that we're passing in arguments to kube control and not Minikube. So an example of that would be this right here, Minikube, kube control, double dash, get PO dash A. Without this separator, this would be interpreted as us trying to pass in additional arguments to Minikube. And we don't want to do that. It'll return an error. We want to pass these arguments to kube control. So that's why we use the double dash. When you're using your alias, because you set your alias to have the double dash, you won't have to type it out again. So that's why we set the alias to Minikube, kube control, double dash. All right. So once you've got yourself set up and situated, you could run Minikube commands. Now this is going to be separated from your kube control commands because again, kube control is what actually runs Kubernetes commands. And when you're running Kubernetes commands through Minikube, you're actually running it through Minikube. Minikube has other commands like dashboard, which allows you to spin up a dashboard, a Kubernetes dashboard. And this is what Kubernetes dashboards look like. You'll be able to see various workloads where you could see your different jobs, your daemon sets, services, configurations, and information about your general cluster. So things like what nodes you have running. Right now, I only have my Minikube node running. And it's handy for visualizing and navigating through a lot of information. But of course, you'll also want to memorize some local commands so that you could run those manually when you're right from your terminal, so you don't have to swap to a different GUI. So let me get out of here. Some commands that we're going to be using are things like kube control, uh, get, right? So get will retrieve information for you. If you want to know about your pods, you could do kube control get pods. You could also shorten it like we saw in the alias before and get pods that way. So you don't have to spell out the whole thing. And if you have multiple namespaces, because notice, well, it's not showing the namespace here, but if we were to do something like get all, or actually, sorry, not get all like that. I meant with a dash A for all. So let's do get pods dash A. We'll see that we have a variety of different pods, and they're all running in various namespaces. Give me one sec, sorry. Just need to make sure if I'm needed or not on this. Oh, so apparently there's a fifth database where this text I need needs to be, but it's encrypted. It's ridiculous. I'm sure they'll be fine without me for a few more minutes. Let's see. Right. We were able to see that we have pods across different namespaces. So if we go back to our dashboard, you'll be able to look at different namespaces through this window. I don't have anything up right now, but this is where you would see them. How we do this at my organization is we build pipelines to deploy our applications when we migrate them to our cluster. We build pipelines to containerize them and have them deployed to a Kubernetes cluster. They'll get spin up on different pods as pods are needed, as activity requires it to scale up or down. And we have a central tool that allows us to manually spin up and spin down different test pods. And this is where we would maybe use various namespaces. So like the practice that we do is namespaces are created from the tickets that you were assigned for whatever tasks are needed. So that's just an example of what you would name a namespace. So Minikube has Minikube dashboard, Minikube cube control, also Minikube status, which will, like it says, show you some status information. So we see that we have a control plane, we have a host that's running, we have a kubelet that's running, an API server, and our config is configured properly. Now, for kube control, we've already looked at get. Again, you could run it on more than just pods. You could run it on nodes, on namespaces, virtually any elements of Kubernetes that you'll need to examine. So if we do namespace, oh, I don't have any namespaces. If you get nodes, we could see that we have the Minikube node. If we do get all, we'll be able to retrieve more information on our cluster. So very handy commands. If you want something a little more verbose, in addition to running get, you could run detail or describe. So if we do a describe on our pods, we can get a lot of extra information like your host ports, your container ID, and IP, all sorts of stuff. So You'll be using kubectl get and kubectl describe a lot. Those are probably your most basic kubectl commands. You'll also be able to run commands that will cover more in depth later on, like kubectl logs, which will allow you to retrieve logs from a node or a pod. Kubectl config view to view configurations, and version to check the version that you have. Now, creating a pod, like many other tools that we've used, pod configurations are written with YAML. So what that looks like is like this example here. You'll have an API version. You'll have a kind to specify what kind of Kubernetes resource you're trying to create. You'll have metadata, which could include things like names, labels, annotations. We'll cover annotations briefly later, and Reno will cover labels a little more in depth tomorrow. Both of those things go under metadata, and you'll have a spec, which then allows you to define the characteristics of your cluster and the containers that it will contain. So in this example here, we have a container that is going to act as our web server, and it's going to be named web server, and it's going to be running Nginx, and we will be mapping port 80 to it. So here's another example. It's the same thing, I think. And if we were to create this right now, which I think I already did, and I'm already running it, so let me exit out of this. The command for this would be to do kubectl apply. And I've already created this pod, so let's just go ahead and, well, actually, let's see, kubectl get pods. You see that we only have one pod, right? If I do my apply again, and I name it something else, or actually, no, I would have to make another YAML. But this allows me to update the existing pod. So if I wanted to make any changes, I would just open up this YAML and make my changes. All right. So from here, we can, if we have a pod running, we could exec into it. So with just like in Docker, we use the exec command, which is short for execute. And this allows us to execute commands in the container or the pod, and we could pass in arguments like -it, which allows us to run an interactive terminal. And then at the end, just like with Docker, you'd be passing in a command to send to your environment or your container, your pod. So in this case, we've exec into the pod, and we can run various commands like curl localhost to see and confirm that Nginx is running. So with that, let's exit out. And that's essentially it for pods and your basic kubectl commands. Let's talk a bit about annotations very briefly. I'm going to actually just push these changes up so you could run through the hands-on labs in here. Let's see. Yeah, read through this. It's not too complicated. We're basically talking about what kind of annotations, which are key value pairs that you could assign to your resources that you could create and include in your resources. Unlike labels, they really have no direct impact on your pods. Instead, it's really just metadata that allows you to pass information like the author of a configuration or something like that. So there are two hands-on labs for this. Once I push the changes to the curriculum, they'll be available. And there's also an assignment that I'll push up. It's a series of different Kubernetes related exercises. And if you don't get through them all a day, just get through the rest of them sometime this week. So let me stop my sharing here. Any questions on any of that?
So for the installation, is there an easy way to just look up what kind of operating system or kernel he's using? The x84, the ARM.
Oh, I feel like I just did this the other day, so let me think. What's the context? Or was this last week or 2 weeks ago?
No, this is just for the installation, where it asks what kind of kernel we're using or what kind of architecture.
Right, so I was just kind of like thinking out loud. I remember running a command for that recently, and I don't know if I did that 2 weeks ago here or if that was for something else entirely. Uh, I don't remember off the top of my head. Yams, are you on your new laptop?
No, I'm in my very, very old laptop.
Okay. Let's see.
Is it just determined by whether it's Windows or Mac? Does Mac use one and then Windows use the other, or
Let's take a look at, let's see, the Minikube. And what operating system are you on? Are you on Windows?
I am, yes.
Okay. Now the instructions for Windows, I think, were a little more complicated. And I've never run through that myself. For Windows, actually, there apparently isn't any other option. You'll only have the option of x86 or 64. Um,
Okay.
yeah, your options will be whether you want to download an executable or use a Windows package manager or use something called Chocolatey.
Hmm.
Right. Try to get it set up. If you have any trouble, just ping me here and we'll hop into a breakout room.
All right, thanks.
I think it shouldn't be as memory intensive as Docker, so you should be able to run it just fine.
Yeah, that is also a worry.
I guess we'll find out.
Um, for this assessment, I'm running Docker in an EC2 container, but I guess I can't do the same for Kubernetes using AWS resource,
Good.
or is that still possible to do that?
Yeah, you can definitely do that. You could set up an EC2 SSH into there and set up Minikube in that environment. You might want to, instead of keeping it up, set up a remote backend to save state and maybe have it configured through Terraform so that you don't lose um, any information like when you're spinning it down or spinning it up.
Okay, okay. All right, thanks.
Yep. Oh, it's still recording. Let me cut